Hi viewers, this is Dr. Gunamani Jana and you are watching video with me on this video series on nature inspired computing techniques. And in this video series today, we will be mainly focusing on this Firefly algorithm. So this is also one of the swarm intelligence. And before I present, let us have a discussion about the outlines. First of all, we will go for the Firefly algorithm, what is the history and the main idea. Then we will go for the behavior of the fireflies, then the characteristics of this Firefly algorithm and the basic steps of the Firefly algorithm. Then we go for the various applications of this Firefly algorithm and finally go for some of the references. Coming to the Firefly algorithm, let us have a look at the history. This Firefly algorithm or FFA, it was first developed by Jinsi Yang in late 2007 and it was based on the flashing patterns and the behavior of fireflies. And this Firefly algorithm, it is a meta heuristic population based method. As you know, most of the algorithm we are discussing in this series, they are all meta heuristic and population based, and this is also a meta heuristic as well as the population based. So let us go for the behavior of these fireflies. Imagine the sky filled with the light of fireflies, and it is a marvelous sight in the summer in the moderately temperature regions especially, and especially in India and these coastal places we mostly see all the things. And there are nearly 2000 firefly species and most of them produce short and rhythmic flashes, and the pattern observed for these flashes is unique for most of the times for a specific species, and the females of the species, they respond to the individual pattern of the male of the same species. So these are the some of the behavior. So coming to the characteristics of Firefly algorithm, the fireflies are unisex, so that one firefly will be attracted to other fireflies regardless of their sex, and the attractiveness is proportional to the brightness, and they both decrease as their distance increases. For any two flashing fireflies, the less brighter one will be move or it will move towards the brighter one, and if there is no brighter one, then a particular firefly, it will move randomly, and the brightness of a firefly, it is determined by the landscape of the objective functions. As you know, for all this fitness value we will be using objective functions at is minimum 1 or we can go for multi. So now we have the we are still continuing, and we declare the light intensity I of r. So this is carried out using this inverse square law IR, which is equal to I0 divided by r square. I0, it represents the light intensity at the source, and the combined effect of inverse square law and the observation, it can be, because for observation coefficient it is gamma, and inverse square law what I have given you, that this one. So I0 by r square, that is I0 into r to the power minus 2, right. So in this way we go for IR, which is equal to I0 into e to the power minus gamma into r square. Okay, so this is the combined effect of this inverse square law as well as the observation, right. Then we move to the basic steps of this Firefly algorithm. As a firefly attractiveness is proportional to the light intensity seen by the adjacent fireflies, the attractiveness function, it is represented by, or it can be established by the equation beta of r, which is equal to beta 0 into e to the power minus gamma into r square. So beta 0, this is the firefly attractiveness value at condition r is equal to 0, and gamma is the media light absorption coefficient. So light will be absorbed in the media, that coefficient is represented by this gamma. Fine. So now this firefly movement, it is based on the principle of attractiveness. When firefly J is more attractive than the firefly I, the movement is determined by the following equations: x of ik, which is equal to x of ik plus beta 0 into e to the power minus gamma rij square into xij minus xjk bracket close, and plus alpha into s of k and this random ik minus half. And here k is a constant which is 1 to capital D, D is the dimension of this problem, and alpha and sk, they are the scaling parameters, and random ik, that is the random number, it varies between 0 and 1, it can be 0.1, 0.2, 0.3, etc. And the distance rij between the distance between the fireflies I and j, they are obtained by the Cartesian distance. The equation is given Rij which is equal to square root of xik minus xjk square, and the k value varies between 1 to capital D. Similarly, if beta is equal to 0, so it becomes a simple random walk. On the other hand, if gamma is equal to 0, so it is reduced to a variant of particle sum optimizations. Okay, so this is also a part of this particle sum. Then coming to the representation of this algorithm. So any algorithm which is population based, initially first we go for the initializations of the parameter, then we go for the initialization of the population, then we go for the fitness value. The same thing also it is done here. The line number 1 or the step number 1, you can see it here. We go for setting the initial value of this randomizations parameter alpha, then the Firefly attractiveness value beta 0, then media light absorption coefficient gamma, and population size p. Previously we are taking n, here we have taken p, and the maximum generation number, that is represented as mgn. Clear? Then we generate the initial population of population xi, that is randomly, and I is equal to 1 to p. So this is just the initialization of the population. Then for each populations we calculate the fitness function, that is f of xi. So this is for all the solutions in the populations. The solutions means it is the xi I am talking about. Then we calculate the light intensity I of I for at xi determined by the FFA function. Then the iteration phase we say t is equal to 0, and repeat this for I is equal to 1, I less than p, I plus plus, and j is equal to 1. That is all the for loop I am using. J is equal to 1, j less than I, and j plus plus. So this is the things, and if the condition, if I of t plus k is less than I of t plus k is less than I j of t, then move Firefly I towards j. Okay, this is the condition. And if and obtain the attractiveness, that is beta, and beta is represented by the equation beta of r, which is equal to beta of 0, that is at the source, so e to the power minus gamma r square. Then we evaluate the fitness functions f of xi for all solutions in the populations, then update light intensity I and for. Then we go for the ranking, rank the solutions and keep the best solution, that is x best. Then we go for the increment t is equal to t plus 1, and this is repeated until t less than mgn, that is the maximum generation number. Fine. So these are the some of the algorithm steps, and then you go for the applications of the Firefly algorithm. There are a number of applications. Some of the important applications we will discuss here. So while we go for the digital image compression, lossless, and the image processing, we can use this Firefly algorithm. Similarly, for the feature selections and the fault detection also we can use this Firefly's the algorithm. So you know that there can be a number of features for a particular object, but the thing is that some of the important features which exactly define that we go for that concept, the feature selections. Then for antenna design, the structural design, for the scheduling, then the semantic web components, the chemical phase equilibrium, the clustering, dynamic problems, and also rigid image registration problems. All these cases we can go for the Firefly algorithm we can apply. Then we can go for some of the references here. As you know, the Jinsi Yang who developed this algorithm. So this is the Firefly algorithm for multimedia optimization in 2010. Then similarly XS Yang, the same Jinsi Yang, in 2008 he developed that nature inspired meta heuristic algorithm, that is the Luniverse Press. Then Jinsi Yang, the same author, the comparative study of Firefly algorithm and particle sum optimizations for noisy nonlinear optimization problem in 2010, like the ISBN number is given. So these are some of the references it is given. So if you I hope I have delivered the minimum concept and explained the algorithm. If you do like this video, please do share with your friends. Also don't forget to subscribe this also, so that all these new videos without any delay they can reach you directly. So once again I thank you for watching this video, and please take care of health. Have a good day. Thank you for watching this video once again.